Hi, good day Dr. Lim. We are from Group Amethyst and our project title is Profit Optimization using Simplex Methods on Amethyst Bakery. So we are consist of 4 people. It's me, Nurbayani, Sarif Sofia, Nur Azila, and also Ali. Let's begin with the introduction. So manufacturing is one of the major industry in Malaysia. It contributed 23% of Malaysia GDP in 2018 and it's growing. So as a growing sector and among the top industry, it is crucial for every business that runs in this sector to pay attention to details, especially on their product and also the way they run so that they could still exist and operate in this current business environment. Harringen and Porter mentioned that more and more companies are being faced with the need to cope with an end game due to today's world of little or no economic growth and rapid technology change. And furthermore, in addition, during economic recession, small businesses are often hit the hardest and forced to shut down due to several factors such as budget constraint, reduced spending power, and also due to inadequate. However, in the other hand, small businesses show remarkable flexibility and find creative ways to survive a downturn. And in this project, you are taking Amethyst Bakery, who is a small company that have been operating for 5 years in Malaysia, and due to recent COVID-19, their business have been impacted. Acknowledging the importance of obtaining maximum profit at minimum cost to survive as a small company, we will elaborate on problems faced by Amethyst Bakery to find the optimal solution in their production and boost their performance. As they are unable to fully utilize their sources due to lack of understanding of mathematics to solve their production process, we use Simplex Method in this discussion to solve the optimization problem as level of profit, production factor, and goods produced are linearly related.
Hi, I will explain about our research methodology. So, we choose to use linear programming in this project. So, linear programming is used for obtaining the most optimal solution for a problem with a given constraint. Linear programming is a simple technique that we can despite complex relationship through linear function and then find the optimum points. According to Catherine Lewis, to formulate linear programming, it can be structured as shown in this slide. So the first step in defining to formulate a linear programming, first you will need to define your variable. A variable is a label that represents a number or a quantity that is unknown or can change. Second, you will need to define the objective function. The objective function of a linear programming problem is the whole point to the problem. So there are questions we need to answer are what are we trying to do? What is our objective? In this project, we want to maximize the profit of our bakery. And third, you will need to write the constraint. Each constraint will be separate inequality. In linear programming, for problems involving more than two variables or problems involving a large number of constraints, it is better to use solution methods that are adaptable to computer. One of the method is called Simplex Method that we decide to use in this project. Simplex Method is developed by George Danzig in 1946. It provides us with a systematic way of examining the vertices of feasible region to determine the optimal value of the objective function. The general form of objective function equation to maximize is as shown in the slide here, where you have the objective function and then where z is the objective function, cn is the coefficient of profit per product package for each xn. Xn is a decision variable to n, Sn is a slack variable to n, AMN is a resources requirement for each Sn, BM is the number of resources available, n is the number of decision variables from 1 to n to n. M is the number of type of resources used step from 1 to m.
First, we need to find the decision variables involved. The variables are x1, x2, x3. As such, x1 is the flavor bread, x2 is the long x2 is the long bun bread, x3 is the white sandwich bread. Next, we need to find the problem constraints. As we see in this problem, we have 18 constraints. We have 18 constraints. Third, we need to create the objective function. So the objective function will be to maximize the z function. As such, z equal to 1.5 x1 plus 4.5 x2 plus 4.1 x3. Fourth, we need to replace all the inequalities with equal sign by adding a slack variable such as s1, s2, s3, etc. If the inequality is an upper bound such as less than or equal, s1 will be positive. Otherwise, s1 will be negative.
Next, I am going to explain on the calculation of profit optimization using Simplex Method. For using Simplex Method, first we need to identify our decision variable. For Amethyst Bakery, there are three variables, which is x1, flavored bun, x2, long bun bread, and x3, white or sandwich bread. Next, we are going to determine the constraint in solving our problem. In this problem, there are 18 constraints in total. The next step is to state our objective function z using the decision variable. The calculation for Simplex method are done using Octave programming. The coding for Simplex method in Octave programming is actually pretty simple. We just need to input the coefficient of our objective function in C, and in A the coefficient of our constraint, and for B is the boundary of our constraint. We are using sense as -1 because our aim is to find the maximized value of z. After putting all the inputs, we just then need to run the program, and the program will iterate in order to find the maximum z value. The result shows that the optimum production for bread x1 is 3,600, for bread x2 is 1,386, while for bread x3 is 500. By following this optimum production level, Amethyst Bakery will be able to gain a profit of 12,069 ringgit and 71 cents monthly.
As we see, the actual values were flavored bread 3600 and the optimum value is 3600. Long bun bread was 1250. The new value will be 1386. White sandwich bread was 500 and the new optimum value will be also 500. As we see, the new total profit is 12,069 Malaysian ringgit when it was 11,455 before the optimization.
The optimum gain optimization model for Amethyst Bakery can be obtained by producing 3,600 packages of flavored bread, 1,386 packages of long bun bread, and 500 packages of white sandwich bread. As you can see here, Amethyst Bakery is able to increase their profit by 5% by implementing the Simplex Method, which is from profit of 11,450 ringgit per month to 12,069 ringgit per month. Therefore, we can conclude that Simplex Method is a good solution for organization to use in order to achieve profit optimization. Thank you.
Here is the list of references that we have used to help on our project. That's all. Thank you.